So we're going to go ahead and do Chapter 6. And the first part of this first section is just some asking us to give some numbers. So what we're going to do here is answer these questions. An integer between, okay, give a number that satisfies a given condition. So, and we're going to do this kind of like a number line answers. So if we have a number line and we have a number of 4.5 and there's a number 5.5 that's to the right of it because it's greater, then the question is find some integer between 4.5 and 5.5. So it's going to be greater than 4 and less than 5. So the answer is 5. So an integer is just a whole number, but also the ones you can have both positive and negative values of. A rational number between 2.8 and 2.9. Well, rational numbers are anything that a number that has a finite. Well, there's two reasons. If you have a finite number of decimal points, then you definitely have a rational number. You can also have a rational number that's kind of repeating, but it has a certain pattern to it. You can take like 1 divided by 11, you get 0.09999 or something like that, or 9191. I forget what exactly it is. Just get my calculator out. If you take 1 divided by 11, you get 0.09090, and it keeps repeating. So that is a rational number because it can be formed by the ratio of two integers. And 2.8 is 28 divided by 100, so those are two integers, and 2.9 is equal to 29 divided by 100. So it's asking for a rational number between these two. So again, if we have something that's greater than 2.8 and less than 2.9, right in the middle is 2.85. Again, it has a finite number of decimals to it. Therefore, it is a rational number from that perspective. Okay, just check to see if I'm recording. But you could have put 2.81, 2.82, 2.83. I mean, there's an infinite number of answers. A whole number that is not positive and is less than 1. Well, so less than 1, it has to be 0, -1, -2, but -1, -2 are negative numbers, so the only one that's that is, oh, okay, whole numbers starts with 0, 0, 1, 2, 3. So this is not integers, it's whole numbers. So you have whole numbers which are 0, 1, 2, and 3. So the only whole number that is less than 1 is 0, and it is not positive. 0 is not positive or negative. So the answer is 0. Number 4, a whole number greater than 4.5. Okay, whole numbers start at 0, and then you count. You have the natural numbers. So you have 1, 2, 3, 4, 5. Counting numbers 1, 2, 3, 4, 5, etc. So the next number that's greater than 4.5 is 5. But there, it doesn't say the first whole number greater than 4.5. Just says, so it could be 5, or it could be 6, or 7, or 8, or 9, whatever. Number 5, an irrational number that is between the square root of 13 and the square root of 15. Well, if you have the square root of 14, which is between 13 and 15, since 14 is between 13 and 15, then the square root of 14 is between 13 and 15. Of course, there are other ones. Any number between 14 and 15. Just hold on a second. For some reason, my thing is not working. Okay, don't know why. Now it's working. So, you know, we can have the square root of 13.1, 13.2, square root of 13.2. So any number that's between those two will be fine. 6, a real number that is neither positive nor negative. So there's only one number that's neither positive or negative. That's 0. Okay, so that's the first 6. Let's go ahead and do 7, 8, 9, and 10. These are short ones. Every natural number is positive. natural numbers and counting numbers are the same thing, and it doesn't include 0. So this is true, that there are all natural numbers are positive. Every whole number is positive. Well, whole numbers include 0, and 0 is not positive, so this statement would be false because of the one exception, which is 0. Every integer is a rational number. That's true, because integers are like 1, 2, 3, 4, 5, or -1, -2, -3, -4, -5, and so they are all rational numbers because you can always divide them by 1, so you can create a fraction, and it just turns out that the denominator is 1. So the answer to that one is that every integer is a rational number. And number 10, every rational number is a real number. That's also true, because a rational number is made up of a ratio of 2 integers, and integers are real numbers, and therefore the ratio of the 2 would be a real number. So that is true. Okay, so let's do number 11. It says, list all numbers from each set that are natural numbers, whole numbers, integers, rational numbers, irrational numbers, and real numbers. So A, say the set A is going to be all natural numbers. Natural numbers are positive, not including 0. 0 is not positive, so it's the counting numbers. So it's going to be 1, 2, 3, 4, 5, 6. So if we look through that list, we see that 3 and 7 are in that set. Okay, B is whole numbers. Well, the only difference between whole numbers and natural numbers is that you include 0. So it's going to be the same list as that, except it's those 3. So you include 0. C, integers can be both positive, negative, and 0. So we have -9, we have 0, we have 3, and we have 7. So those are integers. And D is rational numbers. So as long as it's not an irrational number, it's a rational number. So that's one way of looking at it. You can also say that any fraction is a rational number. So, and also all integers are rational numbers. So -9 works, -1 1/4 because it's a fraction, -3/5 because it's a fraction, 0, 3 5.9, which can be represented as a ratio of 59/100, so that works, and 7. So those are all rational numbers. Irrational numbers are the square roots. So this set includes negative the square root of 7 and the square root of 5. So any square root involving, I don't know if this, I mean, square root of 4, of course, is 2, so that's isn't just because it has a square root doesn't mean that it's not, that it's irrational. But I think, I'm trying to think, probably anything but ones that you can actually get a integer, actually a whole number. And then F is real numbers. Well, they're all real numbers, so I'm just going to say all. The only time it would be 8. Well, actually, there would be one case, and that's in the next. I don't even see it in the next one. Here's an example of something that wouldn't be a real number. If you had the square root of -5, that's not real. It's imaginary. So, looking at both of the examples, and they both don't have a negative square root of a negative number. Okay, let's go on to problem number 14. Use an integer to express each number in boldface print, representing a change or measurement in the following application. Use an integer to express the number in boldface print. That just seems so easy. I'm trying to make sure I wasn't making it harder. So 15, the New York Times Tower is 1,046 feet high. So the integer to represent the bold-faced number is 1046. So that seems pretty easy. Let's look at 18. The boiling point of chlorine is approximately 30 degrees below 0 degrees. Okay, so since this is below, it means that it's less than, and so the answer is negative 30 degrees. Okay, let's do 20. Population of DC. Between 1990 and 2000, the population of the District of Columbia decreased by 31,840. Because it's decreased, it's negative. It's negative 31,841, whatever it was. And let's do 21. When wind chill speed is 30 miles per hour and the actual temperature is 15 degrees Fahrenheit, the wind chill factor is 5 degrees below 0 Fahrenheit. So we actually have three numbers in that particular problem. We have 30 miles an hour, which is positive. We have 15 degrees Fahrenheit, which is positive because it's above 0. And then the final one is 5 degrees below. So because it's below, we can represent that as a negative number. Okay. Graph, let's go to 25. Graph each number on a number line. So let's make a number line. So here it is. It's a line. There's some numbers on it. We're going from negative 6 to positive 4, so we need at least 10 markings. Let's make it 12. So let's go from negative 6 to positive 6. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We'll start here at, actually let's start at lower than the lowest number. So we have negative 6, 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. Let's add a few more here. 5, 6. So negative 2 is associated with that. Negative 6 is right here. Negative 4 is right there. Again, they're negative because they're to the left of 0. So 0 is kind of what splits it. To the right of 0 is positive, to the left of 0 is negative. And the more left you go, the more negative you get. The more right you go, the more positive you get. Okay, then we have 3, which is here. Oh, that's actually 2. Not what I wanted to get rid of that. Okay. 3. Not 2. 3. And this is 4. And so you can look at this, it's not in the question, but you know, by their relative positions on the number line, you can say whether something is greater than something else. So negative 2 is greater than negative 4. Negative 2 is greater than negative 6 because this is more to the right. 3 is greater than negative 2 because it's more to the right. You can say negative 2 is less than 4 because less than means it's more towards the left on the number line. Okay, let's go to 31. Find the additive inverse or opposite of each number and the absolute value of each number. So we have negative 2 is the number given. So part A is the additive inverse. The additive inverse is always the same distance from 0 but on the other side of the number line. So if you have a negative 2, the additive inverse is positive 2. So you really just change the sign. And then B, the absolute value is you just get rid of the negative sign. So if it's negative, it becomes positive. If it's positive, it stays positive. And so the answer is going to be positive 2 in both cases. Okay, let's go to 34. So 11, the additive inverse is this is 11 units to the right of the 0, so 11 units to the left of the 0 is the additive inverse, which is negative 11. And the absolute value is if it's positive, it stays positive, because the absolute value is the distance from 0. And the distance is always positive, so whether you go to negative 11 or to positive 11, it's always the same distance. One goes to the left, one goes to the right, but it's still the same distance. It's like if I go from Clifton Forge to Covington, it's 11 miles, and if I go from Covington to Clifton Forge, it's 11 miles. We don't have a negative distance. Okay, what do we got next? 37. 7 minus 7. So when you add the additive inverse to a number, you get 0. So the additive inverse, so this is a result of the subtraction. The additive inverse of 0 is 0. That's the only number whose additive inverse is the same. And the absolute value of 0 is also 0. Let's see how many more problems we got here in terms of breaking it up. Okay, I'm going to stop on that one and we'll create a new video in here in just a second.